All right, so lesson 6.1 is all about properties of exponents. And there is actually a lot of properties, so just pay attention. More you work with them, easier they will get. Okay, so the first two core concept or the properties is the zero exponents and then negative exponent. So the zero exponent, so what it means is for any non-zero number. So if you take a number and raise it to the power of 0, no matter what, it's going to be 1. So if we take 4 to the power of 0 is 1. 8 to the power of 0 is 1. But that 8 cannot be a 0. Okay, so that's one rule. If you take 0 to the power of 0, it's actually undefined. So it has to be any non-zero. So 0 to 0 is undefined, but any non-zero number raised to the power of 0 is always 1. So why don't we look at actually example A. So evaluate each expression. So what you have here is you have 6.7 to the power of 0, right? So it is 6.7. I like to add parentheses because it's easier to see. So any non-zero number raised to the power of 0 is always 1. That's an easy one. That's it. So let's look at the second property. The second property is negative exponents. So for any integer n and any non-zero number a, when you have a raised to the power of a negative exponent n, it is reciprocal of a to the power of n. And I'll tell you guys what it means. So if you have your number and you're raising it to a negative exponent, think about it as what's 4 as a fraction? 4 over 1, right? So it is the reciprocal. So you almost flip it so it's 1/4, or you kind of like moving that 4 into the denominator, and by doing it, you now have a positive exponent. So let me show you guys. Actually, let's do it on this problem, and then we'll go back to B because B is a little more complicated. So here's my number raised to a negative exponent. You cannot ever have negative exponents. So we know 3 is the same thing as 3 over 1, right? So this is the same thing as us moving that 3 into the denominator, right? So now we have the reciprocal. And then by moving into the denominator, that the negative 3 became a positive 3. It's kind of tiny. So if I simplify it, this is the same thing as 1 over 3 times 3 times 3. Or we can just plug it in the calculator. And I want you guys to grab your calculator. I know you guys probably know what that means, what that is. But 3, and if you have a graphing calculator, so if you click 3, if you click this button, that little hat, raise to the power, and if you plug 3 in, what do we get? 27. If you have the blue calculator, so it's 1 over 27. If you have blue or any other regular, because at home you guys usually have these ones. So you will go 3. Raised to the power is right here. That's tiny little box, right? With a little, almost like a hat or carrot, they call it. To the power of 3, and then hit enter. You'll still get the same answer. So you really can use whichever calculator you want today. Now, let's look at this one for a minute. So, what's raised to a negative 4th power is actually negative 2. See how there is a parenthesis? They're telling us that negative 2 is being raised to the power of negative 4. We cannot ever have negative exponents, so we're going to kind of flip it, right? It's going to be 1, right? And you put that negative 2 is still there because that's the integer. The only thing that will change is the exponent. Then negative 4, because you moved it into the bottom, it's becoming positive 4. But then integer is still negative. So, what are we going to get? It's 1 over what? Is it positive 16 or negative 16? So we have positive, negative, positive 16. What are we thinking? What do you think is positive? Okay, so it is positive, and I'll show you guys why. Whenever you have a number as an exponent that is an even number, if this is negative, that becomes positive answer. I'll show you guys both of them. Let me grab a different color so I don't think it's the same problem. So here's an example. See the difference between negative 2 raised to the 4th power. That saying is negative 2 times negative 2 times negative 2 times negative 2. So as you see, right, negative times negative, it's positive, times negative, it's negative, times negative, it's positive. So that's 16. Notice the difference in the writing. If I have negative 2 to power of 4, what's the difference between the two right now? Like, what do you see? Parentheses, right? If you have parentheses, you're taking everything that was in it, right? Right here, what you assume is that you have negative, and the only thing you're taking to power of 2, to power of 4, is that 2. So technically, you will have negative, and then 2 times 2 times 2 times 2, and therefore, what would this answer be? Negative, right? 16. Negative 16. You really need to recognize the way of writing with parentheses versus non-parentheses. What is being taken to power of x, to whatever power actually. Okay, so let's do number 2, or actually the evaluation 2. That's actually a great example of what we just talked about. In the numerator, where it's being raised to the power of 0. Is it negative 5 or is it 5? What do you guys think? But what is being taken to the power of 0? Is it 5 or is it negative 5? It's actually 5. Good job. So what you really have is negative. And on the beginning, you can write parentheses if you want, if it's easier for you to see. And then divided by, and I'll just copy this because we really looked at the numerator first. So we know we have to move this to the numerator, right? Because that's negative. So in the numerator, we have the negative left. What's 5 to the power of 0? 1, right? 1. If I move this to the numerator, so it's times 2 to the positive 2 power, and then there's only 1 left in the denominator, right? So if we simplify, we have negative 1 times, what's 2 squared? 4. I guess let's have that 1 in there. Negative 1 times 4 is negative 4. Do I have to have that 1 underneath? No, right? So we'll just leave it as negative 4. That is your simplest form of this expression. Okay, let's look at example number 2. Simplify the expression, obviously knowing all the rules we just talked about. So here we have 4 times x to the power of 0 divided by y raised to the negative 3rd power. Okay, what exponent does 4 have right now? 1. Just 1, right? So I'm not doing anything with that 4. I will just copy it. What's x to the power of 0? 1, right? Anything to the power of 0 is 1. And then what do we have to do to get rid of this negative 3? We have to move all of this into the numerator. So times y. And now our 3 becomes positive. If you want, you can have that 1 underneath, just kind of because you're learning. But you can actually drop it. So if you simplify it, 4 times 1 is 4. Y to the 3rd, and that's your final answer. That's your simplest form. Do you guys want to try 3 on your own? Try it on your own. See if you can apply some of the properties, and I will do it with you guys. So we have 3 to the negative second, we have x to the negative fifth, and then we have y to the power of 0. Maybe simplify it, right? We have to move that 3 into the denominator. So 3 and now becomes positive second exponent. We have to also move that x because we have a negative 5. So now it becomes positive. And then what about the denominator? We have y to the power of 0. And you think the power of 0 is 1, right? So we can just change it times 1. What's left in the numerator? 1. Remember, it's a reciprocal, right? So technically, that 3 to the negative second power was negative over 1, right? So you just took the reciprocal. So now that 1 went to the numerator. So we're almost there. So we have 1. What's 3 squared? 9. X to the fifth. Y, not y. 1 is just 3 times 9, which is cancels out. That is it. Or this one. You guys are ready for more properties? We have 5 more. What? So much fun. All right, here they come. So 3 more. Here we have product of a power property. So what it means is if you want to multiply powers with the same base, you're going to add their exponents. So same bases, right? We have 4 to the 6th times 4 to the 3rd. The base is that integer, so it's 4, right? So you have the same base, you're just going to copy 4 and then add 6 plus 3. So this is our example A. Product of powers. So here is my example. Simplify each expression. Write your answer using only positive exponents. So my base is 3, right? I have 3 to the second times 3 to the 6th. So when you have that, you're going to add the exponents. That's part of the property. Okay? Add the exponents. So now we have 3. What's 6 plus 2? 8. And we are going to simplify it more. So we can go 3 times 3 times 3, 8 times. Or you can grab a calculator and say 3 raised to the power of 8. Make sure you try to plug it in today with me to make sure it's working. Because once you're at home and you start working, I cannot help you. And what do we get? 6,561. Plug it in and see if you get that. If you want to see it one more time. So it was 3. You plug 3. Raised to the power is right here. 8. And then press enter. Okay. Yes. If you wanted to take 3 to the second times 3 to the 6th and add them up, you'll still get the same answer. Now, this property is very helpful for later on for kind of complicated expressions, and we'll see them tomorrow. So it's good to know the property. All right, so what I want you guys to do is try this one. Simplify number 4 right now. 10 to the 4th times 10 to the negative 6th. This is the product of powers property. Product, because you're multiplying the bases. Let's see what we'll get. What are you guys getting? 10 to the what? Negative second. Remember, using only positive exponents. How can you make that exponent positive?
1 over.
Yep. So it's 1 over 10 to the positive exponent 2, which is just 1 over 100. Okay, ready for the next one? So our next one, we have quotient. Quotient just means it's a fraction. That's what quotient is. So if you have a fractions that have the same basis, you're going to subtract the exponents. Now, when I was your age, I always struggled, which one do I subtract? from bottom or bottom from top. Whatever you have first, that's what you copy minus the bottom. So let me show you guys. So this is example B. So what's my base? Do I have to flip something to the bottom because there's some negatives here? No, we only look at the exponents. Good job. So my base is -4. You always start with whatever was there minus the one in the denominator, always. So if you simplify it, you have -4 raised to the power of -5. Using positive exponents only, we have to change this into the denominator. Now notice how that -4, it's still just -4. It's only the exponent that changes. So we're taking the negative to the power, right? What do you predict the answer is going to be? Positive or negative? Predict. If exponent is an even number, you'll have a positive answer. If it's an odd number, you'll get a negative answer. What do you guys think? Negative. So right away, you know it's going to be negative. You can assign the negative to the fraction. And I'll show you guys both ways. So if I have 4 raised to the power of 5, right? Because we know it's already negative. Or if you forget that, you can have parentheses, negative, raised to the power of 4, to the power of 5. So here's the answer. So we do have that 1024. So the fraction is -1 over, can you guys see it? Oh yeah, you do. 1024. All right, you guys try this one, but be very careful. Look at the things we talked about back here. Look back at example 1B. When you're trying to do number 5, see if you remember. See if you can pick up what's going on back there. So try 5. Notice the negatives. The negative in the actually integer is not being raised to the power. See how I rewrote them? They're not being raised to the power. So I have negative, and then 5 is being raised to the power of 8. And then in the denominator we have negative. 5 is being raised to the 4. So technically, now when you have a fraction of a negative over negative, what is that? Positive. So they actually cancels out right away. So we have the same basis. So now we have 5. Always start with whatever was there minus whatever is in the denominator. So we have 5 to the power of 4. Log it in. The power of 4. See if you're getting the same answer as I am. Make sure you practice the calculator part. Did you get 625? So that equals 625. Now we have our third one on this page. So that's for the example C. So when you're doing this at home, you can kind of remember. This one is called power of a power property. And what it means that if you have a number that is being raised to the power, but you're taking it to another power, so if power of a power, you will multiply the exponents. So power of a power, you will multiply the exponents. When you had division, you were subtracting the exponents. So this is the product, this is the quotient, this is the power of a power. So what it means that I have a z, power of a power, you're just going to multiply the exponents. So we have z, 4 times -3, you get -12. Using positive exponents only, that means I have to actually rewrite it and put it into the denominator. So it's 1 over z to the power of 12. You guys try number 6 on your own. Power of a power. You guys get 36? Yes? Awesome. Good job. Okay, two more properties, and we're going to pause for today. What question do you have so far? When you're doing homework, make sure you have this worksheet in front of you. Make sure you look at the examples. Look at all the properties, the powers. All right? Okay, so last example with two more properties. This one is power of a product. Power of a product. Product is multiplication. So here is power of the product. So what they're saying is if you have in parentheses numbers that are multiplied together, and then that parenthesis being raised to another power, to a power, you're going to almost like distribute the power to every single thing in the parenthesis. So see how we have 3 now to the power of 5 times 2 to the power of 5. So right now, if you look at example 4, power of a product, we're multiplying two things. We have negative 1.5 times y, right? Can you see that? So you're going to rewrite them as negative 1.5 to power of 2 times y to power of 2. It's almost like distributing that power. And notice the negative is originally in the parentheses, so it's going to stay there. Negative raised to power that is even will give us positive exponent, or you can say negative 1.5 times negative 1.5, and that will give us positive. And if you take 1.5 squared, it's going to give us 2.25. What's y squared? Just y squared. It's positive exponents. This problem is finished. Let's look at actually 7, because it's the same kind of property. Here we have product, in parentheses, we have 10 times y. That should be your clue, that you have to actually almost like distribute that number. There's actually 2 ways of doing this problem. I'll show you guys both of them. So this is the first one. So 10 to the negative third times y to the negative third. Notice we have 2 negative exponents, right? So what you do have to do is we have to move them into the denominator. So we have 1, so it's 10 to the third, y to the third. What's 10 to the third? What do we get? 1,000? 1,000. And y to the third. Can I show you guys another way of doing this problem? I'm going to say or. Whoop. Notice how this is negative. What I could do is I could flip inside of the parenthesis and flip my fraction right there. And now this one becomes positive. So now if I distribute, I have 1 to the third over 10 to the third, y to the third, and we are back in the same spot because 1 to the third is just 1. So 2 different ways of doing it. This is the more common. It's whatever you're comfortable with. Okay, one more property. We have the quotient. Quotient is a fraction. So here's our last one for today. Lots of properties. If you have a fraction that is being raised to power, you're just going to distribute the power to the numerator and to the denominator. So if you look at this one, so this actually we have the power of a product first, right? So we're going to distribute 2 to the negative fifth times x to the negative fifth. And then, so we did the numerator, but now we have to assign it to the denominator. Notice how I am just distributing that exponent. There's a bunch of negatives going on, right? Bunch of negative exponents. So we have to rewrite things around. So I know I have to move this exponent to the bottom and this one to the bottom first. So that becomes 2 to the 5th times x to the 5th. And then we actually have to move this one to the numerator. So that's 3 to the 5th. And if we simplify it, we end up with 3 to the 5th, which is 3 raised to the power of 5, which is 243. 2 to the 5th is 32. X to the power of 5. That is our final answer. What we could have done, also, another method, is if you actually reverse your fraction first, so if I reverse the fraction, then that becomes positive 5. And if you distribute, you get the same answer. So whichever way you prefer, it's all the same thing. Okay, you guys try number 8, and then we are done for today. So we have 1 over 2k squared, and this whole thing is being raised to the power of 2. Every problem is very unique, have different properties within one problem. So I have 1 to the 5th, and then 2 to the 5th. And now we have k that is already being squared, but now it's being raised to that 5th power. So here we have power of the power property. So what's 1 to the 5th? So it's 1 times 1 times 1 times 1 times 1. Just 1, right? What's 2 to the 5th? 32. We just did that one, right? But here we have power of a power. So power of a power, what do we do with exponents? We multiply them. Awesome. So if you multiply them, we have 2 times 5, which is 10. No negative exponent. This is our final answer.